Welcome to Ciena Chalk Talk. I'm Steve Alexander, Senior Vice President and Chief Technology Officer at Ciena. Today, let's discuss the future of networking. In the past, networks were purpose-built for specific types of products or services. This used to be true right down to the physical layer. Copper networks were built for legacy voice, coax networks for video, and wireless networks for mobility. Entirely different networks were usually built for the distribution of images, voice, text files, sensor data, or real-time communications. Today, things can be different because these discrete networks can all be replaced with common network infrastructure. This can then be leveraged as an open and programmable platform that increases service velocity and prepares you for the future. As you modernize your infrastructure, you don't want to lose the attributes of service-specific networks. You want the same benefits of customization, of making the service fit the mission, but now you also want the ability to simultaneously support multiple missions over a common infrastructure. You want to be able to leverage network analytics and intelligence as well as software control and automation. At Ciena, we call this combination of a programmable common infrastructure with analytics-driven network intelligence the adaptive network. Let me give you an example. Look at a simple network with partitioning for mission support. I want to run this on a common infrastructure and see how it works. It can be desirable to partition a network for many reasons. In one area, I might be supporting a specific mission that requires low latency and a special suite of sensor data. I can create a mission-specific slice of my infrastructure to make sure that the resources needed for this mission are not impacted by any other competing demands. My services in this case remain highly available, are independent of any other missions, and I am able to replicate all of the key characteristics of an independent network in that mission slice. The last thing I want to do is impact or drop these critical services. I want the network to enable the mission, not impede it. It should be just like the air we breathe. The network is just there. It adapts to any demands I place on it. I use as much as I need for the success of all the missions I am supporting. So let's talk about our thinking when we build an adaptive network. When we first started to build networks, it was around connecting physical locations together. Then we started to connect people together with the wireless network. Now we're building networks that connect machines together. It's that combination of locations, people, and machines that drives the demand for flexible bandwidth, and that requires the adaptive network. You want your infrastructure to be open, highly instrumented, and programmable. You want the network to adapt to the mission requirements and to provide the services and user experience you need to create. Add in the challenge of doing all of this in an environment with accelerating demand for connectivity and capacity, along with new services, and you can see why a new networking paradigm is necessary. When we construct an adaptive network, it must be done in a faster and more cost-effective way. If the network needs to expand to be 10 or 100 times more capable for today's missions, it can't cost 10 or 100 times as much. We must be able to bend those cost curves down and let the network costs grow at a much, much slower rate than the network capabilities. What we've captured here is what is called a cost and complexity pyramid. As you go to higher layers in your network, the number of interfaces, the associated data plane and control plane touch points all serve to increase cost and complexity. To make the most efficient use of network resources, traffic needs to stay optical as long as possible. This generally minimizes cost, complexity, and latency simultaneously. You still need the different layers to build a complete network infrastructure, but you want to optimize how you use each one of them. You want to keep traffic at the lowest possible layer of your network as long as you can. This is important because whenever higher layers touch the traffic, the additional processing generally cost, uses more energy, and often adds additional latency. Additionally, you must optimize between routing, switching, and transport because you are going to be dealing with a tremendous amount of packet-based traffic. Multi-layer visibility and control are the keys to being able to optimize the cost of your network. There are fundamentally 4 critical things that go into building your adaptive network. First, right down at the physical layer, you want to use open and programmable coherent optics. That's how you're going to solve your transmission issues. This is the foundation of your infrastructure. Just like the foundation of any structure, pay attention to it. It's what everything else relies on. Second, you're going to need to use a distributed control plane. That's how the different network elements are going to communicate with each other. Third, You're going to utilize virtualized switching and routing to provide segmentation and compartmentalization mechanisms to allow multiple types of traffic to peacefully coexist. Today, we can partition at layer 0 using different frequencies of light, at layer 1 and 2 using different encapsulations, and at layer 3 with segment routing and packet labeling. We can slice the network using these combinations of technologies to provide time-sensitive, robust, virtual, mission-specific networks. This creates a multi-layer, multi-domain set of virtual networks, all using a single cost-effective physical infrastructure. The final thing you need are APIs, the application programming interfaces. This is how you'll communicate with the components of your network platform and how the elements will communicate with each other. If you do these things, you also optimize packet transport versus packet touch. This bends your cost curves down. Your network can grow to be 10 or 100 times more capable while still minimizing cost and complexity. The principles we've talked about are part of Ciena's adaptive network vision. These architectural principles are how we build mission-critical, multi-domain, multi-tenant networks for service providers all over the world. At Ciena, we believe that the adaptive network is the desirable end state. It fully leverages programmable infrastructure, analytics and intelligence, software control and automation allow us to adapt to the unpredictable demands and applications of tomorrow.